Welcome to Mathenatic. We are busy revising content for paper 1. In this video, we'll prove that the sum to n terms of a geometric sequence can be given by this formula. So this proof is one of the proofs that you need to learn for paper 1. First, let us establish what Sn means. Sn is term 1 plus term 2 plus term 3 all the way up until the last term that we consider in our pattern. In the previous video, we learned that term 1 is equals to a, term 2 is a times r, and so forth, and the last term, Tn, is represented by a times r to the power of n minus 1. So in order to prove this equation, what I do next is I multiply every term by r. So term 1 multiplied by r, term 2 by r, term 3, and so on. So what will happen is if I multiply the first term by r, I have ar. But instead of writing it underneath here, can you see that a times r is shifted up? So this empty space doesn't represent anything. I am just shifting it up to show you a times r is ar. And what I'm trying to do is I'm trying to write like terms underneath one another. But if I continue multiplying every term by r in this first pattern, I'll end up with a last term of a times r n minus 1 times r to the power of 1. And if I use exponent laws, I have a times r to the power of n minus 1 plus 1. Because these bases are the same, we can add exponents together. And that simplifies to a times r to the power of n. So that's what we have in our last term. That means that ar to the power of n minus 1 represents the second last term in the pattern. So by writing it in this way, we can now subtract the second line from the first line. So imagine that I'm saying Sn minus Rsn. So every term here in the second line would become minus because we are subtracting. And can you see that all of these terms would cancel out? And we'll only be left with a, which is the first term, minus the result of the last term. So minus a times r to the power of n. Because everything in between has cancelled out. So on the left-hand side, we have a common factor of Sn. So I factorize out the Sn, and I'm left with 1 minus r. So if I take out Sn in the first term, I'm left with 1. And in the second term, I'm left with r. On the right-hand side, I see a common factor of a. So if I take out the common factor, in the first term, I'm left with 1. And in the second term, I'm left with minus r to the power of n. Now, I can divide both sides by 1 minus r. So on the left-hand side, by dividing by 1 minus r, I'm left with Sn. And on the right-hand side, I'm left with a times 1 minus r to the power of n divided by 1 minus r. And that is where the equation of Sn for a geometric sequence comes from. Thank you for watching. Support us by liking and subscribing to Mathenatic. Check out our Digistore for math study notes, with free downloads for statistics and financial math. Follow the link in the video description.